Hi everyone. Today in class we started talking about unit circle trigonometry. And so remember that we're taking this concept of an angle in standard position where the initial side is on the positive x-axis and the terminal side rotates around the vertex. And so now the terminal side intersects the circle at a point. And so that's represented by an ordered pair, which is x comma y. And then remember the radius of the circle is 1. Okay, so basically we can take that angle and make a right triangle out of it. And then we can use SOHCAHTOA to find sine, cosine, and tangent of that angle. And so we get these new rules. Sine of theta is equal to y, cosine of theta is equal to x, tangent theta is equal to y over x. And then we have our reciprocal function. So cosecant theta is 1 over y, secant theta is 1 over x, and cotangent theta is x over y. All right, and then that led to what we call the unit circle. And so if you weren't in class today, you'll want to pause the video and fill this out in your notes. And so the unit circle basically represents different angles. Okay, so all of these segments represent terminal sides of angles. So for instance, you know, this angle would be a 45-degree angle. And so we started by filling in all the angle measures in degrees, and then we converted all those to radian measure. And then we used our special right triangles to find x and y, which, remember, help us find all 6 of the trig ratios for each of these angles. Okay, so that's where we're headed to now. All right, so before we do that, we need to talk about what's called a reference angle. Now, if theta is an angle in standard position, the reference angle, which we use this symbol to represent the reference angle, associated with theta is the acute angle formed by the terminal side of theta and the x-axis. So your reference angle is always formed by the terminal side and the x-axis. Okay, so I have 4 different scenarios here, and if you notice, the 4 scenarios are created by the terminal side being in each quadrant. Okay, so let's look at these. When the terminal side is in quadrant 1, theta is actually equal to the reference angle. Okay, so they're one and the same. So for instance, and we're just going to use pi over 4. If, let's just say, theta is equal to pi over 4, then the reference angle is pi over 4. Okay, now when the terminal side is located in quadrant 2, like in the next example, so let's find an example. Let's say that theta is 3 pi over 4. Well, if we're trying to find the angle formed by the x-axis and the terminal side, if this is theta, the way we can find our reference angle is to take 180 degrees, or 1 pi, and subtract theta from it. Because if we did that, basically this is 1 pi. If we subtract from that theta, then we'll be left with the reference angle. Okay, so let's go back to our example. If theta is 3 pi over 4, then the reference angle is pi minus 3 pi over 4. But of course, we're subtracting fractions, so we need a common denominator. So we'll just make this 4 pi over 4. And then we just subtract our numerators, and notice 4 pi minus 3 pi is 1 pi over 4. Okay. Now, if you look at the third example, this time our terminal side is in quadrant 3. And so if we want to find our reference angle, we're just going to kind of reverse what we did in the last example, because if this is theta, then if we subtract 180 from the reference angle, then, or from theta, excuse me, so theta minus 180, or in this case 1 pi, that's a subtraction symbol, then we'll get our reference angle. So basically, if this is theta, if we subtract 1 pi, we'll be left with the reference angle. Okay, so let's say that theta, excuse me, is 5 pi over 4, which is in quadrant 3. Then to find our reference angle, we're going to take theta and subtract pi, or 180. Okay, so then we need a common denominator, so we'll make that 4 pi over 4, and notice that if we subtract our numerator, 5 pi minus 4 pi is again pi over 4. Okay, now last one, terminal side is in quadrant 4. And so if you think about it, to find your reference angle, if this is theta, then we could just do 360 minus theta, a full revolution minus theta, and that would leave us with the reference angle. Now remember that a full revolution in radians is 2 pi. So we could just do 2 pi minus theta to get our reference angle. Okay, so let's use the example here that theta is 7 pi over 4. And so we're going to find our reference angle, 2 pi minus 7 pi over 4. But we're going to have to get a common denominator. Move that out of the way. So we're going to convert that 2 pi to 8 pi over 4 minus 7 pi over 4. And you may notice that we get pi over 4 again for our reference angle. Okay, so this was kind of set up like this. If you notice, all of these angles have the same reference angle, which is pi over 4. Okay, so this is going to help us when we're using our unit circle, because this is how you use your unit circle to evaluate trig functions for any angle. Okay? Number 1, you find the reference angle associated with the angle. Determine the sign of the trig function of theta by noting the quadrant in which theta lies. The value of the trig function is the same, except possibly for the sign. Okay, so whatever angle you are finding the trig functions for, if you find the reference angle, the trig functions are going to be the same for theta and the reference angle, except for maybe the signs. Okay, so it depends on what quadrant theta is in. Now, this is a mnemonic that can help you remember the signs. So this represents which trig functions are positive in each quadrant. And so if you can just remember, all students take calculus, it'll help you remember the ASTC. And this is telling you that all the trig functions are positive in quadrant 1. Sine is positive in quadrant 2. And that also includes its reciprocal function. So actually sine and cosecant are positive. In quadrant 3, tangent and cotangent are positive. And in quadrant 4, cosine and secant are positive. Okay? But the all students take calculus can help you remember. All right, so let's see how this works in action. This is where we've been heading. All right, we want to find the exact value of the trig function for the given angle. Now, another thing you may have noticed with the reference angle, the denominator is always the same. So finding your reference angle is really easy. Okay, so here in number 1, theta equals 2 pi over 3, which means its reference angle is pi over 3. Okay? All right, so if you can, again, just remember quadrant 1 on your unit circle, you have to think, okay, what is the ordered pair at pi over 3 on the unit circle? Well, that's 1/2 square root of 3 over 2. All right, then think about which quadrant theta is in. 2 pi over 3 is in quadrant 2. Okay, so in quadrant 2, if we go back, or you can even just think of plotting points, in quadrant 2, sign is positive. Okay, or just think about plotting points. If I plot this point, then x is negative, y is positive. Now sign is the y coordinate. Okay, that goes back to these rules right here. Sign is equal to y. So we have our answer. Sine of 2 pi over 3 is equal to square root of 3 over 2. Okay. All right. Cosine of 7 pi over 6. I'm going to put a blank there this time. We want to find cosine of 7 pi over 6. So again, think of the reference angle. The reference angle is pi over 6. Think of that ordered pair. Square root of 3 over 2, comma 1/2. All right? Think about which quadrant 7 pi over 6 is in. 7 pi over 6 is in quadrant 3. So in quadrant 3, both x and y are negative. Okay? All right, and then remember cosine of theta is equal to x. So we have our answer right here. Cosine of 7 pi over 6 is equal to negative square root of 3 over 2. All right, let's look at tangent of 7 pi over 4. And again, we're trying to figure out what that is equal to. Start with your reference angle. The reference angle is pi over 4. Okay, then think of that ordered pair. It is square root of 2 over 2, square root of 2 over 2. All right, then think about which quadrant 7 pi over 4 is in. That's in quadrant 4. So in quadrant 4, x is positive, y is negative. Okay? Now, remember, tangent theta is equal to y over x. So, if we take y and put it over x, that's just going to equal negative 1. Because you're dividing the same thing by itself, but you have a negative divided by a positive. So it equals negative 1. All right, so now we're going to look at some examples with the reciprocal functions, but the process is the same, okay? All right, so this time we want to find cosecant of negative pi over 6. And so again, start by finding the reference angle. Now, actually, before we do that, this is one thing that we didn't have to do in the first 3 examples. 2 pi over 3, 7 pi over 6. And let's just scroll down. Not letting me. Okay, anyway, these angles were all on the unit circle, meaning they're between 0 and 2 pi. Negative pi over 6 is not from 0 to 2 pi. So actually what we want to do is find the co-terminal angle between 0 and 2 pi. Okay? So let's do that first. So remember, that just means we're going to add 2 pi but we need a common denominator, so we're going to add 12 pi over 6, and that's going to give us 11 pi over 6. Okay? All right. So then, find your reference angle. The reference angle is pi over 6, because the denominator is always the same. All right, think of that ordered pair. It is square root of 3 over 2, comma 1/2. Okay. Now, think about which quadrant 11 pi over 6 is in. 11 pi over 6 is in quadrant 4. So in quadrant 4, x is positive, y is negative. So this is the ordered pair for 11 pi over 6, which is coterminal with negative pi over 6. So again, it has the same terminal side, okay, which means it has the same terminal point, same ordered pair, same trig ratios, okay? All right, so now, remember that cosecant theta, cosecant is the reciprocal of sine, so it equals 1 over y, which is another way to say flip the y coordinate. So this is equal to -2, which is the reciprocal of -1. Okay, moving down. All right, 5 pi over 2, that is not between 0 and 2 pi. So again, we're going to start by finding our coterminal angle. So we're going to subtract 4 pi over 2. And we're going to get pi over 2. Now, the reference angle is pi over 2. Okay. So again, this is 90 degrees. So if you think of that ordered pair, it's 0, 1. Okay. So, to find cotangent, remember, cotangent theta is x over y, okay? So if I put x over y, that'll be 0 over 1, which is equal to 0, okay? So cotangent of 5 pi over 2 is equal to 0. All right, last example. We have secant of 13 pi over 3. Now again, 13 pi over 3 is not in between 0 and 2 pi. So we need to find that coterminal angle. In this case, we'll subtract 2 pi. And so we have a common denominator. We'll make that 6 pi over 3. All right, and so when we initially subtract, we're going to get 7 pi over 3. But notice that is still not between 0 and 2 pi, so we need to subtract again, and we get pi over 3. Now, pi over 3 is in quadrant 1, so it's the same as its reference angle. So just think of that ordered pair. The ordered pair at pi over 3 is 1/2, comma, square root of 3 over 2. All right, now we want to find secant. So remember, secant theta, secant is the reciprocal of cosine, so it's 1 over x. So basically, we just need to flip the x coordinate, and this equals +2. All right, so this is how we use our unit circle to evaluate these trig functions. As you can see, it involves just about everything we've talked about up until this point. So I know that it's going to take some time before you memorize your unit circle, but definitely start with quadrant 1, okay, because you can see how important quadrant 1 is, because those are your reference angles. And so if you can figure out those ordered pairs, then you just have to think of the signs based on the quadrant that the angle is in, okay? So do some studying, and I will see you tomorrow.